All right, so part 5, let's talk about outcomes. And in this section, we'll talk about some analysis as well, because that goes hand in hand with outcomes. So first of all, with any study, any journal club, anything, you absolutely need to know what was the primary outcome. So I had an experience when I was a student when I completed a journal club and I showed a specific graph, and my preceptor said to me, but what was the primary outcome? And I said, oh, well, this graph shows it. And that preceptor said to me, that's a secondary outcome. You don't know what the primary outcome is, and you don't understand the journal club. And granted, this was kind of intense feedback to get in the moment, but ever since that experience, I had it drilled into me. You absolutely need to know what the primary outcome is. And you need to know how the graphs relate, because usually, not always, but usually the primary outcome is expressed in a graph. So you need to understand the differences between the graphs and what the graphs show. So whenever you're reading a journal club, don't skip over the graphs. If anything, read the graphs and the captions below. The captions below will often give you great insight into what the graph is showing. Sometimes they'll explicitly state this is the primary outcome showing this. They're very, very helpful. So when you're going over your outcomes, make sure that you differentiate what is the primary outcome and what are secondary outcomes, because you need to make it clear to the audience that you understand what the primary outcome is. And it just, again, it's part of that storytelling part of the journal club that this is what they found. This was the primary outcome. So this specific study, they express their primary outcomes in hazard ratios. So hazard ratios, it's a little bit of a misunderstanding that hazard ratios are percentages, because they're not percentages. So a hazard ratio is basically just a comparison between probabilities. So it's a comparison between the probability of an event happening in your treatment group compared to the probability of that same event happening in the control group. So the treatment group, we usually consider that to be our intervention, so the study drug. And then the control group, usually that's placebo, but sometimes it's another drug that we know works. Sometimes it's, something completely different. So it's really important to understand that hazard ratios are not percentages. They are comparisons of probabilities. So how do we actually interpret a hazard ratio? So you can consider a hazard ratio of 1 to be both sides, both probabilities are equal. There's no difference between the probabilities. So that means that the event is just as likely to happen in the control group as the intervention group. There is no difference. However, if the hazard ratio is greater than 1, that means, depending on how they're expressing their data, that means the event is more likely to happen I guess it depends on how they're expressing their data, but it can change. So 1.20, that does not mean 1.2%. That means a 20% more likelihood of it happening in a certain group. Similarly, say you have a hazard ratio of 3. That means that there are 3 times the number of events seen in the treatment group at any point in time. So usually it's not an either or. So just because, say if you have a hazard ratio of 0.3, that doesn't mean that the control group is 0.3 times more likely. What that means is the treatment group is, 30% less likely to have that event. So it's not a seesaw. If you need a visual analysis or a visual picture, it's not a seesaw. Whatever conclusion that can be made by hazard ratio is always in terms of the treatment group. So another example, say this hazard ratio right here. This hazard ratio is 1. So that means that there was no difference in cardiovascular, composite cardiovascular disease between the two groups. So in this study specifically, we were looking at 2 different medications, and this study found that there was no difference between the 2 groups. I want to note that hazard ratios can be confusing. So what I recommend you do is now, while you're starting rotations, create a document with the term, so hazard ratio, and then the explanation in your own words as a table or, whatever format that you prefer, but create that document. So if you forget, oh, how do I interpret a hazard ratio? You can refer back to that document with examples, and you can kind of refresh on what it means in your own terms. Because a lot of times, in my experience, I've heard students give a presentation, and even myself, before I really understood, is that you'll basically read verbatim what it means from a website explaining the definition. But that doesn't matter if you don't understand the definition. It doesn't matter if you just read it off, because you need to understand how it affects the results. So just kind of to go over it one more time, the hazard ratio tells you the risk of an event expressed as a probability at any point in time of that treatment group. Again, it's focused on the treatment group and not the control. So if we have the hazard ratio equaling 1, that means there is no difference in probability that an event would occur between the 2 groups. So sometimes this works in our favor, because sometimes we're trying to show that they're equal, and sometimes we're trying to show that one drug is better than the other. So you also really need to understand the objective of the study, because say we're looking at a non-inferiority trial, and you say, oh, there wasn't any difference between the 2 groups, so the study drug is not good. That's not true. What we're trying to show in a non-inferiority trial is that the study drug isn't worse than the control drug, or our standard of practice drug. So you need to understand what the objective of the study is, and you need to understand what hazard ratio means. So a lot of times a hazard ratio will be expressed on a forest plot. And this is kind of, this is what a forest plot looks like. Usually the line down the center, that's going to be the null hypothesis. So that's meaning that there's no difference between the 2 groups. And that's always equal to 1. So if your confidence interval, which is this little bar here, if this crosses 1, there is the chance that there's no difference between the groups. So just because, maybe the actual hazard ratio is a little bit, off of 1, that doesn't mean that it's significant, because if the confidence interval crosses 1 at all, that means that there is a chance that there's a chance that the 2 groups are the exact same. And then one other thing before I move on is that it's really important to note there is no such thing as almost significant. So let's pretend that, these little bars were right so close to not being crossing 1. If it crosses 1, it's not significant. There's no difference, I should say. There's no such thing as, oh, this was almost statistically significant. That does not exist. It's either statistically significant or not. So if you say you have a hazards ratio that is 0.99 to 1.2, just because that 0.99 was so close to crossing 1, so close to not crossing 1, I should say, that does not mean that it's almost significant. It just means, it's not significant. There's no difference between the 2 groups. So There are no kindas basically with statistics. Similarly, with your secondary outcomes, you can see that these, none of them cross one. So that means that there's a higher probability of the event occurring in the treatment group. So none of these cross one, so we can be confident that we can actually make some clinical statements about these. And then safety outcomes. It's really important to talk about safety outcomes if the researchers gathered it, because how safe the drug is for our patients is always relevant. We always want to know, is the drug safe for our patients, and can we safely recommend it to somebody? So if they include safety outcomes, please do talk about them.